That's us. So, yeah, you're all very welcome to this, which is the fifth in our series of webinars. Today we'll be covering machine vision and robotics for inspection. My name is Ronan Rasdale, and I work as a robotics and automation sales engineer with Reliance Automation. We'll be joined later today by David Moore from Visca Systems, who will give an overview of his company and in particular his highly impressive visible solution for inspection. We're all probably fairly familiar with Zoom at this stage after the couple of months we've had. But if you have any questions, if you can please pop them in the chat area and we'll try our best to answer them as we go along. The webinar will also be recorded and the link will be available under the events and news section of our website, which is all the W's relianceautomation.ie. So on screen, we have a brief agenda for what we'll be covering today. Basic introduction into Reliance and who we are, what we do. We'll then look at why we might need a vision system for a robot. We will look at vision-guided robotic systems and inspection and metrology robots. We'll then tackle the 2D versus 3D vision question. And then we will look in a little bit more detail at Visible from Visca, which is, as I said earlier, an excellent automated inspection system. We'll then look a little bit at resources and financing, etc., and questions and answers. Total time, I would say, is somewhere between 30 and 40 minutes. Reliance Automation. To begin with, we'll start with a brief run through of Reliance Automation. On screen are just some of the brands we represent within the automation sphere. If you visit our website, relianceautomation.ie, you'll see a more comprehensive list. I'd also encourage you to follow us on LinkedIn and indeed Instagram if you're that inclined. So Reliance were established in Cork in the 1920s and are now a fourth generation Irish-owned family business. We're the largest technical distributor of maintenance and automation products in Ireland. Over the years, Reliance has diversified its portfolio and exclusively represents many brands, which we've seen on the previous slide. So we strive to provide superior technical expertise while ensuring excellent value and a high level of service is consistently delivered. Reliance is classified as an essential service provider and has remained open during this period for our customers. If you look on screen, you can see two images of Reliance. The top one is our Cork office, circa 1928, and the photo below it is our Cork office as it stands today in 2020. So almost 100 years at this stage, Reliance has been in existence and going from strength to strength. We have three branches, Dublin, Limerick, and our head office in Cork. I myself am based out of our Dublin office, but our automation team are spread across all three of our branches. What's important to note is that Reliance Automation are a technology distributor. We are not an integrator. Many of the brands we represent have out-of-the-box or turnkey solutions that are quite easy to set up by customers with little or no automation experience. However, for more complex projects, we have a long-established relationship with many machine builders, the length and breadth of the island of Ireland. So no matter where you are in Ireland, north or south, or what you're involved in, Reliance Automation and their partners can offer you a complete solution. So we move on to the topic of today's webinar, and look, why might we need robot vision? So in basic terms, robot vision involves using a combination of camera, hardware, and computer algorithms to allow robots to process visual data from the world. For example, your system could have a 2D camera which detects an object for the robot to go and pick up. A more complex example might be to use a 3D stereo camera or nest of cameras to guide a robot to mount wheels onto a moving vehicle. Without robot vision, your robot is essentially blind. This is not a problem for many robotic tasks, but for some applications, robot vision is useful and indeed even essential. So the list on screen is not exhaustive by any means, but it does cover most of the applications that that we commonly see for robot vision system integration. Components of a vision system. So the combination of robotics and machine vision technology can make for a powerful automation solution with far greater capabilities than any other technology can achieve on its own. Robotic vision systems come in many forms and they can be used in a wide range of applications. Typically, it's a camera, lighting, vision software, and one or more robots, possibly with the camera mounted on them. The lighting may or may not be needed, but it must always be a consideration. In Reliance Automation, we have many vision partners. Cognex are the market leader in machine vision, with approximately 1 million systems installed worldwide. Cognex has robust solutions for both VGR applications and inspection. Their ever-increasing range of 3D incorporates 3D area scanners and laser profilers. Sensor part of a product called Visor, and Visor was specifically developed for the challenges in robotics applications. So an integrated, standardized interface there, so it can be easily incorporated in existing plants and robot systems. They now also have a 3D offering with depth precision from Helios, which is a Sony solution. On robot then, over on the top on the right-hand side, they're one of our main end-of-arm tooling suppliers. So in the gripper and indeed screwdriver sphere now as well. But they have in recent times developed a product called Robot Eyes. Eyes offers depth perception. So it's an affordable, easy deploy 2.5D vision system. So compared to 2D, it adds not only length and width, but also height information for the specific part, which is ideal when objects vary in height or indeed if they have to be stacked. And also on screen there, you'll see Solomon. Solomon offer an out-of-the-box 3D vision system. So AccuPick is their solution for bin picking, and Solomon VGR for robot guidance. They're both very, very easy to use 3D vision systems. Pickett then, over on the left-hand side, also offer an out-of-the-box, plug-and-play 3D robot picking system. And in the centre down at the bottom, we have Visca Systems. So Visca are based in Buttevant and Cork, and they design and build customised, automated, high-accuracy manufacturing and metrology measurement systems. And these are for med device, electronics, semiconductor, and research industries. Said earlier, David from Visca will be on the webinar later to showcase their visible solution for inspection, and it really is a best-in-class inspection system. Vision-guided robots. So a vision-guided robot system, or VGR, is basically a robot fitted with one or more cameras which are used as sensors to provide secondary feedback signal to the robot controller to more accurately move to a variable target position. So it's an ever-increasing technology, and it can streamline the process as well as reduce labour costs and part defects. Vision applications can be mounted upstream from the robot cell or fixed to the robot head itself. As the cost of these systems has reduced, it has led to an increased implementation due to the ability to do away with convoluted means of orientating parts to be picked, which often used up valuable conveyor space too. Inspection robots, on the other hand, are a crucial part of the operations of many industrial sectors. Conducting regular, thorough examinations help to ensure reliable equipment performance, worker safety, and product quality. Robotics is playing an increasingly central role in conducting inspections. Today, robots can inspect manufacturing equipment, pipelines, buildings, transportation systems, and much more. Automation capabilities are improving, costs of these technologies are falling, and it's enabling more and more companies to take advantage of the benefits they provide. Increasingly, we are seeing a huge demand for automating end-of-line inspections. This is due to the repeatability and the reliability of the robot inspection. The robot will inspect all parts 24/7 with the exact same thoroughness. Human error can be eliminated. The latter part of this webinar will be dedicated to inspection robots and visible in particular. Look here at 2D versus 3D. So in the case of a pure 2D machine vision system, the target object image acquired for processing is effectively a flat, two-dimensional plan view. The 2D image does not provide any height information at all. There's X and Y data, but no Z-axis depth of field data. What we see is effectively the contours of a 3D object viewed from a specific viewpoint. Different viewpoints and different objects create entirely different contours. This makes 2D vision of limited use in applications where shape information is critical to performing a task. The lack of height and true shape information, though, is of little or no consequence for many reasonably simple applications. So as a result, 2D, either area scanning or line scanning, machine vision systems are used extensively throughout the industry for a wide range of tasks. These include verification of features and positions, dimension checking, barcode reading, character recognition, OCR, label verification, quality inspection, surveillance and object tracking, and presence detection. You can see here, Cognex system, and that's from a show where it's simply picking the parts up from the field of vision and putting them into the assigned box. Limitations of 2D. 2D does have some limitations. Too much light, too little light, or shadowing in the factory environment can adversely affect the clarity of the edges and the features appearing in the 2D plane. So sensitivity to lighting can be an issue. Moreover, since it's these clear contrasts, and thereby the edges and the features in the target object surface the 2D depends on, then it will also struggle to handle both very, very dark or very shiny objects. While there are lots of different techniques for lighting up an object, its edges and features can be difficult to pick out. Plus, of course, since we're not handling any height information with 2D machine vision, errors due to target object movement in the Z plane presents a further limitation. If the object was always sat on a perfectly flat surface at a precise focal distance from the image sensor, then it wouldn't be an issue for imaging accuracy. Finally, and by definition, 2D machine vision systems can't cope with the intricacies of three-dimensional shape or form, especially for complex parts and assemblies where the dimensions need to be measured other than in the X or Y plane, where a part's volume needs to be determined, where a part needs to be picked and placed in a precise fashion, such as from a bin randomly, then 2D vision may not be up to the task. It simply doesn't recognize shape. One new possible solution is the product mentioned earlier from our partners On-Robot Eyes. The On-Robot Eyes makes it easy and affordable to deploy vision for almost any collaborative application. So it's ideal for sorting a variety of objects, CNC machine tending with metal parts that are defined by outer shape, and other pick and place applications where orientation is important. 2.5D vision does have depth perception, so it can then, where height is an option, so for stacking, for example, it makes this system ideal. It can be reconfigured very easily, so there's an adjustable wrist, or indeed you can mount it externally. And they have a system called One System, which is set up that makes it easy to integrate with any leading robot brand. You have one picture calibration and part recognition as well, so there's no need to load in 3D drawings or anything like that. So it can integrate seamlessly with the robot interface and the gripper through their quick changer as well. So we're finding for simple pick and place applications, CNC machine tending, things like that, where you do need to see the height of the object, this is an ideal solution. You can see there as well, some of their other grippers, etc., also on the slide. "3D. In a 3D machine vision system, the target object is no longer just a flat picture. Now there's a three-dimensional point cloud of precise coordinates where the position of every pixel in space is known. So it simultaneously provides X, Y, and Z plane data along with respective rotational information around each of the axes as well. By virtue of being able to capture the extra third dimension data reliably, 3D machine vision systems are relatively immune to the environmental factors that adversely can affect 2D systems. So the aspects of lighting, contrast, and distance to object that we discussed earlier are generally no longer an issue. Because we're working with a highly accurate three-dimensional digitized model of a target object, machines can now comfortably handle both shape and position. They know a target object's precise location in space, its volume, surface angles, degrees of flatness, and features, irrespective of the production line environmental conditions and whether the object is semi-shiny or light absorbing black. This greatly simplifies target object fixturing and overall system design. Here in this video, we have a 3D system helping a robot to carry out a random bin picking task. This is often seen as the holy grail of vision systems. So here, the 3D camera is passing location and orientation information to the robot for picking. Say this type of bin picking, you'll see it all over YouTube. It's kind of the holy grail. Now, we ourselves would question how often we actually see this scenario in the real world. However, applications are out there and they do exist. There's often a way to avoid having to randomly pick from a tote, but these do show the capabilities of a 3D system very, very well. It's only possible for a 3D system to be able to do this because it needs X, Y, and Z info to be able to establish the location and the orientation. Now, there are some pitfalls, and we'll get to those shortly. But as I say, these are more and more common, and there is a race now from 3D vision providers to be able to provide an out-of-the-box solution that is capable of doing this sort of bin picking. Both Solomon and Pickett do offer such a solution. Now you can see the field of vision here and how they're working. Often you'll find that it doesn't clear the bin, and you may have to empty the tote into the bin behind it in some of the applications. 3D, because of it, we have a lot of advancements. So there are some applications that now can be tackled due to the capabilities that 3D has brought about. So thickness and height volume measurement, dimensioning and space management, detection of surface or assembly defects, measuring shapes and holes, and quality control verification against 3D CAD models. And then, as we've seen, bin picking and random parts that are stacked on top of each other. I would caution, however, that 3D is not the panacea to all vision system challenges. Every application should be looked at on its own merits. There are circumstances where a 2D vision system will still win out. Do not think by adding an expensive 3D vision camera or system that all the challenges are gone. A great 3D application takes a lot of design work and upfront testing to make sure the process runs as expected. Thankfully, our partners are more than happy to work with us on these. So if you have a potential application, please share it with us and we can work with our partners to come up with a solution. They'll happily take samples for proof of concept, etc. Considerations for 3D, your end of arm tool clearance for bin picking. Make sure that the robot path avoids the collisions with the tote or the bin itself. Other considerations around processing times, part to part. These are improving constantly, however, they're still slower than their 2D counterparts. Accuracy as well, 3D bin picking in particular, By nature of the parts all being on top of other and perhaps the end of arm tooling being moved or slipping off one onto the other, don't assume it's 100% just because it's 3D. Many 3D vision systems will have a secondary fine positioning solution before the robot passes the part on to another process. And then finally, cost. Although costs are falling, the addition of a 3D vision system will still increase the return on investment time significantly, and unfortunately will negate many applications and make them unviable. So at this point, I'm going to pass over to David from Visca, and David will run us through his little bit on Visca and then their visible solution.
Hello, everyone. Can you hear me, Ronan?
Yeah, can indeed, David. Yeah, just give me a second. I'm just going to put up your presentation here. Give me 1 second. Just out of one and into the other one. I think that's the right one, David. Yeah, there we go.
Yeah, perfect. Just want to make that full screen there.
Yeah, just give me 1 second.
So thanks anyway for that nice first slide deck, Ronan. Very good information in there. I think you touched on some really good points, so hopefully everyone can take something away from that, I'm sure. So, yep, I'll start. Yeah, so my name is David Moore. I am the CEO of Visca Systems. And yeah, so we're based down in Buttevant, down in Cork. We're running since 2015. And our specialist area is, specialist type of automation. So we work in three main areas, which is machine vision, robotics, and doing custom software to link those two areas together. So we like to simplify that as saying we help machines to see, to move, and to think. My own background, originally I'm a mechanical engineer, and in my PhD time, I worked a lot on a variety of different technologies. My specialist area is around high accuracy motion control and also around high accuracy metrology. So measurement down at sub 10 micron level. That would be my kind of specialist background. Visca works with a variety of companies globally. We're about 40% export. And yeah, we have I suppose, a very nice variety of projects that we work on, ranging from robot integration, ranging to doing difficult inspection tasks, and then also making things industrial Internet of Things compatible. So we do a lot of custom work along that. If you could just go to the next slide, Ronald, please. So as I mentioned, we work in those three main areas: machine vision, robotics, and software development. And what we really find is working in those three areas gives us an advantage as a company when it comes to integrating complex inspection systems, because they're very complementary kind of areas. The vision itself has a lot of detail around how you implement image processing strategies. So we really are able to help our customers get the best out of their investment in equipment by using our experience with lighting, optics, and all the different applications that we come across to be able to optimize those things. From a robotics side then, we have a lot of experience around high accuracy motion control. So from movements down to single digit microns, that's quite an area that is becoming more and more popular as I suppose inspections become more frequent and with higher tolerances. And also the size of parts manufactured reduces. And then in terms of software development, we are National Instruments partners. So we're the market leader in Ireland for LabVIEW software development. And we do a lot of custom software development in that environment for different customers as a service, and then both to develop our own products. Next slide, Ronan, please. One of our key partners in the supply chain, along with Reliance, will be Cognex. So we're key integration partners for Cognex in Ireland. and we work with a big variety of their technologies. So from smart cameras, which are basically high power machine vision cameras. It has a camera with a high power PC built into the back of it, and it can do very quick and very easy to set up machine vision tasks. They're really suitable for fixed, I suppose, fixed camera applications. So if you imagine that you have a manufacturing line, you're producing milk cartons, for example, and you want to read the date on the carton and you want to do different inspections on the carton, that is something that suits a fixed camera application really well. Moving on from that then, we support Vision Pro and ViDi Deep Learning. So these are two Cognex products. Vision Pro is a product that's been around for a while. It is their image processing library, and we would integrate custom PC applications that can leverage the power of this library to do custom inspections on different parts. The newest technology on the market is really this deep learning. So deep learning itself is a subset of AI, artificial intelligence, but it works, this particular subset of AI works really, really well for complex vision inspection tasks. So what we can do is, by collecting a variety of images, we can actually train a neural network to perform the same type of inspections that a human would. So it can give automated inspection a human level of perception. And previously, that would have been extremely challenging to do using traditional classical image processing algorithms. The good thing is also that this type of technology has become a lot easier to use. The user interface is a lot easier. So we're using this now to great effect in implementing automated inspections for customers, where they have, particularly for customers that have, say, a lower volume. So they're not making millions of parts per year. They're making maybe a few hundred to a few thousand parts per year of any particular type. And what has made this technology easier to use is that the training of these neural networks has become easier because we need less data to train them. So it kind of opens up a whole new suite of applications. And in a couple of minutes, I'll show a video where we use our product, which I'll talk about next, which is called Visible, to be able to program the robot to leverage this power. So as Ronan also touched on, 3D measurement is a very important area. There are definitely considerations, especially if you're thinking about doing highly accurate measurements. There's definitely considerations to think about where 2D can still be advantageous over 3D, but definitely for many of the part handling and picking applications that Ronan mentioned, it's really a kind of new technology that's getting better and better all the time and is opening up a whole suite of applications for automation. Next slide, please. So today I'm going to talk to you a little bit more about our new product, which is Visible. So Visible is a robotic vision inspection solution in general for the manufacturing industry. And what it is a bit of software that sits between a robot and between a custom camera head that we've developed. And it makes it very easy to use image processing with a robot. So the pain it really solves, I suppose, at the moment is that if you have a robot, the robot itself might be easy to program. And if you had a camera, like a smart camera, that might be easy to program for an individual inspection task. However, if you have multiple inspection tasks to set up, the interface to robot with the camera was a little bit troublesome. So we developed this product to make it very easy to use and implement for our customers, and they can achieve really quick return on investment. So we've had some customers that as little as 2 to 3 months, they've had a return on investment of the whole robot and camera and visible installation. So the whole premise of the idea is that it's quick to run. And in a couple of minutes, I'm going to show you a video of how we set up an inspection plan, an automated inspection plan, in only 4 minutes. Next slide, please. So as I mentioned, Visible, it's a software product. It connects at the moment to a couple of robots, UR E-Series being one of them. And it also connects then to our custom camera head, which you see on the right of this screen. And it interfaces with libraries such as Cognex ViDi. So that's how we enable the whole deep learning thing. If you just on the next slide, please. This is an example of the user interface. So what we've developed here is an inspection plan as an example. And you can see that it's fairly clean user interface. All the different inspection points that have been defined are shown in that box on the left-hand side. Basically, what you want to do when you're doing robotic inspection is you want to get a robot to move to a location and then to do a specific task when it gets to that location. So this is what this whole software interface enables. Next slide, please. So for today's demonstration, we have a UR3, and it's inspecting just the front of this press drill here. I'm going to show you how to set up two simple inspection locations, one to check for that spring presence and the other is the wing nut presence. The speed that this is going at is not so much like a tutorial, but it's going to be more like, you know, if you're an experienced user, this is how quick it is to set up. So if you just play that video for me, Ronan, please.
One second there, David. I'm just going to share my video.
Excellent.
Back to the start.
Yes, please. Yeah.
Yeah, there we go.
Start there. Yeah. So as you can see, the robot is in its kind of upright home position. So the first thing that we want to do here is to add that as a home waypoint. So there is a wizard that you step through to add an inspection point, and it allows you to set up waypoints. Then we control and drag a copy of that to create a copy of that, so it'll go back to the same position at the end of the whole inspection plan. At the moment now, you can see me, I'm adding an extra waypoint so that the robot doesn't collide with the assembly when it's moving into its inspection position. So you can see I'm using the free drive functionality of the UR robot to be able to manually move it to that approximate waypoint position. I then click next and next again, and that waypoint has now been added. So now we're ready to set up our first inspection point. Is that still playing, Ronan? Yes, I think there. So we're just going through the whole wizard here, and where you can see there that we're just dragging down the robot to bring that spring into the field of view. So we can see that there's a spring available there. And we click next in the wizard then, once we configure our kind of camera parameters and brightness. So all the settings for each inspection point are saved relative to that inspection point. So here we're just using a Search Max, which is a simple pattern matching tool. So we grab the image from the camera. We select the template of the object that we want to find, which is the spring. And I'm just going to test the image here. So we see, oh yes, it's passed. So you can see a little green cursor in the center of the image where that object has been found. So if I put something in the image like my fingers, but the spring is still visible, it still passes. And if I check again and block it completely, it'll say the inspection has failed. So that's just a quick sanity check to show that the camera is actually working. So we'll now add our second inspection point, which is the wing nut inspection. Again, we'll hit free drive and drag the camera into position. So we can see the wing nut there. You can also see a reflection of the ring light on the camera head. So I'm just kind of moving that around to minimize the glare. So you can see there are settings there also for exposure and gain, so you can control the camera settings at each point. And the other advantage of using a 6-axis robot is that you can use the Cartesian move coordinates to jog the robot in an XYZ fashion relative to the part once it's in position if needed. So again, we're just going to select our template, test the camera image, we see it passes, and if we block it then, we see that it fails. So an example of, I suppose, where in practice you might do this one a little bit differently is that the orientation of that wing nut might be different. On an assembly line, it might not always be that orientation. So you might just actually use a different orientation, look at the wing nut head on perhaps, might actually work better. Now I'm just dragging a copy of that WP1 waypoint. And now we're ready to start running our inspection plan. So I'm just going to jog the robot out back to its own position as to avoid any collisions. So I'm jogging the points one by one by selecting them in that menu and hitting run inspection point. And now you can see that the robot has moved to its own position, and now we're ready to run the full inspection plan. So if we press yes, And robot moves to the first position, takes a picture, moves to the second position, takes a picture. And that's it. It's now completed an automated inspection. So you can see by clicking on those menu items, then you can actually get a record view of exactly those images that were taken at that time for that inspection. What we've done for some other customers is there's another section to the software called workflow, and that enables communications via Internet of Things protocols. So we have some customers that have implemented a solution like this, but then also have a factory dashboard where they can go back, search all their parts by serial number, and pick up the results of all the inspection points for all serial numbers on their product line. So it's a very nice way to have an audit trail with images of all the different inspection points, with pass-fail results for all your production for the past number of months. So it's a nice way to do it. So I think I just had one last slide, Ronan, just to close that out. Yeah, so just to say thanks for listening today, and I hope that was beneficial. And I look forward to talking more with you. If you are of interest, you can visit us at visca.ie or get in contact with Ronan, who will put you in touch with us. So thank you.
Many thanks, David. Superb once again. I think for anybody considering inspection, especially end-of-line inspection, the visible solution is absolutely superb. We see where I'm just going to go. Okay, my notes are visible there. Just give me a wee second here now, just a minute. Can I exit that? Give me a wee second. There we go. So, yeah, I'll just move on just before we're finishing up here. A couple of things just to cover. Leasing. Obviously, there can be barriers in terms of finance to getting an automation project off the ground. So we do have a solution there. We work with a finance partner called DLL, and we can offer financing for your project. So if you have anything, not only as well, interestingly, not only the project itself, so not only the hardware, but also the integration and all of the ancillaries around the project. So we're not necessarily financing a particular piece of hardware. You can finance the entire project top to bottom. So even for the integrators out there among you, it may be something that's worth considering if you have a customer who maybe from a CapEx point of view may be finding it difficult. It is possible to finance the entire project, including integration in your time through ourselves. A few resources worth taking a look at. Application Builder, which is from the Universal Robots website. So www.universalrobots.com/application builder. In here, you can go in and take a look at your application. Choose the various drop downs, so the type of robot, type of application, and it'll walk you through it. Increasingly as well, On Robot are coming up with a similar application builder on their website, worth taking a look at. E-learning and blogs, again, Universal Robots, good place to start. Likes of On Robot, Robotique, people like that. Videos and case stories. The internet and YouTube in particular is awash with vision applications and sample videos of your particular vision application. So whatever it is, stuff is out there. But most importantly here, I would say technical support and consultation. We can work with all of our vision partners, people like David and Visca, and all of the integrators, the length and breadth of Ireland, to take a look at your particular project, to scope it out, to see what's possible, to give you advice in terms of what's the economy option, what is the all bells and whistles option, and really help you along your automation journey. So if you have anything from an application point of view, a good point to start is ourselves. If you can take videos, if we're not going on site, we can certainly take a look at them and advise. But again, free of charge, we'll happily go on site, take a look at your application, and either directly ourselves or in conjunction with one of our integration partners, be able to come up with a proposal for you. So my number's on screen. My email, ronanrasdale@relianceautomation.ie. And indeed, our website, all the W's, relianceautomation.ie. There's some useful information in there and a contact form. So if any of you should have anything, pop it in there and we'll get back to you. So I don't think there are any questions. So that's about us, as I say, over 40 minutes today, which is longer than most of ours have been. I hope you find it useful. And as I say, if you have any questions or queries, don't hesitate to contact us. The website's a good place to start, all the W's, relianceautomation.ie. Thank you.